this time we're going to go over gases. So gases are a big part of chemistry, and it might have to be split into two parts for this video, but we'll see. So let's get started. First thing to talk about is Charles' law. So that's one thing to keep in mind, and Charles' law is a direct one, and that states that volume and temperature are directly related. So if one goes up, the other is going to have to go up as well. And the graph for that would look like this. This is temperature, this is volume, and since it's a direct relationship, just be a straight line like that. Now, next thing to keep in mind is Boyle's law. Now, Boyle's law is the inverse one, and that states that volume and pressure are inversely related. So what that means is that if one goes up, the other one also has to go down. And unlike the Charles law one for the graph, it's not really a straight line. So if you have pressure here and volume there, it's more like an inverse relationship. So it's going to look like that. So remember, if one goes up, the other one's going to have to go down. So with that being said, let's do one practice problem real quick. Now, the equation to keep in mind for doing most calculations, right? So calculations such as, let's say you have a gas at 5 liters and 4.3 atmosphere and 25 degrees Celsius. Let's make it 20 degrees Celsius, right? And you put it into a container that is, let's say, 2 liters and at 0 degrees Celsius. Now, what would be the new pressure? Now, to do such equations, you're going to have to use the equation PV over T equals PV over T, where P is pressure in atmosphere, V is your volume, and T is your temperature in Kelvin. So let's go ahead and plug and chug. So if you have 5 liters times 4.3 atmosphere divided by 293 Kelvin, because remember that Kelvin equals 273 plus your degrees Celsius. 273 plus 20 is 293, and that equals 2 liters times pressure, which we're solving for, divided by 0 degrees Celsius, which is 273 Kelvin. Now, how do you solve for P? You cross multiply and divide by 2. So we get P equals 273 times 5 liters times 4.3 atmosphere. This is atmosphere. And all divided by 293 Kelvin and 2 liters. Now, liters cancel out, your Kelvin also cancels out, and you're left with atmosphere. Now, if we were to put that into the calculator, right, 273 times 5 times 4.3, all divided by 293 times 2, and we get 10.1, well, 10.01, well, 10.0, sake figs, 10.0, 10 atmosphere, and that's our answer. Now, if you were given a constant temperature, right, if these were the same, then you could have gone ahead and ignored the t's because they don't change, so you could have not used them in the equation, but since they are different, we have to. So just keep that in mind. Now the next thing we need to talk about is partial pressure. jeez. Hold on. Partial pressure. Stem. Okay, so now the next thing we talk about is partial pressure. Now, partial pressure happens when you have two gases, well, two or more gases, in separate containers, and you allow them to mix together. So if we have, let's say, neon gas in here, argon gas in here, and let's say this is at 3 liters at 2 atmosphere, and this is 4 liters, 3 atmosphere, right? So right now, since they're in separate containers, they have different pressures. But if you, like, let's say, if you remove the cork, right, and allow the gases to mix together, they will exert a different pressure. And you'll be asked to calculate the pressure, or rather the partial pressure of each one. So let's go ahead and do that. Now, this is really easy. So remember the equation PV equals PV. Well, that's going to come in handy. So your initials are 3 liters, 2 atmosphere of neon. And you're asked to calculate the partial pressure, which is P2. Now, volume, now the V2 is just a combination of two gases. So 3 plus 4 makes 7 liters atmosphere. So you do divided by 7 liters, and you get, oh geez, 3 times 2 divided by 7 equals 0.85. 0.857 atmosphere. Now that's the partial pressure of neon. What about argon? Well, same concept. So you have 4 liters times 3 atmosphere. That's your initial. And you have 7 liters combination. 4 plus 3 makes 7 atmosphere. Divide by 7 once again. So now if you do 4 times 3 divided by 7, you get 1.7 atmosphere. Now, that's the partial pressure of each gas. What about the total pressure? Well, that's where Dalton's law of total pressure comes in, or Dalton's law of partial pressure. It states that the partial pressure of each gas combined equals the total pressure of the whole container. So the total pressure is 1.7 plus 0.857, and we get a total of 2.57 atmospheres of total pressure. So pretty straightforward.